Hello everybody. There was a request for a solution to this problem, so I'm going to show you how to do it. So here you've got a quotient, and you don't know something like the quotient rule for integration, because that's not a thing. So it seems like you're stuck, but if you think about how you could simplify this, you could actually use the power rule backwards. So what I'm going to do is I'm going to split this into three separate fractions. So if I've got x squared divided by x to the 1/2, that's like x to the 2 minus 1/2, which is like x to the 1.5. And then here I've got x to the 1 minus x to the 1/2 is like x to the negative 1/2. Oops, 1/2. And then here I've got 7 times x to the negative 1/2. Oh, and of course this is positive 1/2 because it was 1 minus 1/2. All right, so dx. So you can apply the identity that the integral of the three terms is equal to the integral of each term separately. So integral, I'm going to move the 3 to the outside. So x to the 1/2 dx. And then 7 on the outside, x to the negative 1/2 dx. So now I'm just going to use the power rule backwards for each of these. So the most general antiderivative of this should be 1 over 2.5 x to the 2.5. Does that make sense? Let's see. If we take the derivative of this, the 2.5 will come down, and these would divide each other to get 1. And then 2.5 minus 1 is 1.5, so that's worked. And then there's an integration constant, which I'll call C0, because each of these is going to have its own integration constant. So then here I've got 3 times the quantity. Most general antiderivative of this should be 1 over 1.5 x to the 1.5 plus my integration constant, which I'll call C1. And then here, and notice that's on the inside of the parentheses. Although actually, as you'll see in a second, it doesn't really matter. And then 7 on the outside. And let's see, so this is going to be 1 over 1/2 x to the 1/2 plus c. All right, so that seems to have worked, although I wouldn't want you to leave your solution in this form because that's kind of gross. So let's do a couple of things. First of all, I don't like to mix decimals and fractions. That's kind of ugly. So 2.5 is the same thing as 5 over 2. So 1 divided by 5 over 2 is the same thing as 2/5. So that's 2/5 x to the 2.5 and then C0. And then here I've got 3 divided by 3/2. So again, 1 over 3/2 is 2/3. 2/3 times 3 gives us just 2. So that's 2x to the 1.5 plus 3 times C1. Here I've got 7 times 2 is 14. X to the 1/2 plus 7 times, C2. All right, so I've got 3 different integration constants here. Usually we don't really have a reason to care about what each of these are separately. So typically what you do is you just combine them all together. You define C4 to be the collection of all of these, 3C1 plus 7C2. And so then you could write your final solution as 2/5 x to the 2.5 plus 2x to the 1.5 plus 14 x to the 1/2 plus C4. And actually, it wouldn't be wrong to just go straight from here. Don't write down the individual constants. Just write a constant sort of at the end. I say that with a little bit of hesitation because there's some problems where you wouldn't want to just tack on a constant at the end because it sort of matters where it comes from. But in this case, I would want you to think through the process that I did. Think, okay, so we've got a constant here, a constant there, a constant here, but really I could just add all these constants together to get a new one that would be its own term. And if you have a situation like that, then it's safe to just put a constant on the outside. If you're nervous about that, there's nothing wrong with going through the same process that I did here. Okay, hope that helped.